Good afternoon. This is Dr. James Rippey. It is my pleasure to be the moderator of today's webinar that is going to be delivered by Professor Jeff Volek. It's entitled Ketones, From Toxic to Therapeutic. I will formally introduce Dr. Volek in a few moments. This is part of the Conagra Nutrition webinar series, and the Conagra Nutrition mission is we believe that everyone deserves easy access to understandable, credible, and science-based nutrition information. I would now like to turn the webinar over to my colleague, Amy Continelli, who will handle today's webinar logistics.
Thank you, Dr. Rippey. CEUs, a link to obtain your continuing education credit certificate will be available on this webinar's page at conagranutrition.com and emailed to you within 2 days. A recording of today's webinar and slides as a PDF will be available to download within 2 days at, again, conagranutrition.com. The presenter will answer questions at the end of the webinar. Please submit your questions by using the chat dialog box on your computer screen. Thank you, Dr. Rippey.
Thank you, Amy. I will introduce Dr. Volek in just a moment, but before that, I need to list the objectives for today's webinar, since this is a CEU activity from the Academy of Nutrition and Dietetics. Today's learning objectives are as follows. Insulin resistance manifests functionally as carbohydrate intolerance and is best managed with a carbohydrate-restricted diet. This presentation will, number one, overview the process of switching from a carbohydrate to a fat-based metabolism through dietary carbohydrate restriction. Number two, discuss ketone metabolism and define nutritional ketosis and keto adaptation. Number three, discuss how a well-formulated ketogenic diet affects the constellation of markers associated with insulin-resistant conditions, including reversal of type 2 diabetes. Number four, review other clinical and performance applications of ketogenic diets. It is now my pleasure to introduce today's presenter, Dr. Jeff Volek. Dr. Volek is a registered dietitian and professor in the Department of Human Sciences at The Ohio State University. For the past 2 decades, he has performed cutting-edge research on how humans adapt to ketogenic diets, with a dual focus on clinical and performance applications to nutritional ketosis. His scholarly work includes more than 300 peer-reviewed scientific manuscripts and 5 books, and he has provided more than 200 lectures at scientific and industry conferences around the world. Dr. Volek's work has contributed to the existing science of ketones and ketogenic diets, their use as a therapeutic tool to manage insulin resistance, including the ability to reverse type 2 diabetes, plus their increasing potential to augment human resiliency. His team at Ohio State University is currently focused on discovering new roles of nutritional ketosis in relation to cancer and military applications. Dr. Volek has a Bachelor of Science in Dietetics from Michigan State University and a Master of Science in Exercise Physiology and Doctorate in Kinesiology and Nutrition from Pennsylvania State University. It is my pleasure to introduce Dr. Jeff Volek.
Thank you very much, Dr. Ripke. It's certainly a pleasure to be here today. I wish I could see everyone's smiling, friendly faces, but I have to say there's something nice about the convenience of doing this in front of your computer, too. So the title of my talk is Ketones, From Toxic to Therapeutic. And part of the reason for that title is if you look at the history of ketones, they've really had a torturous path going all the way back to their discovery, which occurred over 150 years ago. Ketones were discovered in the urine of uncontrolled diabetics, and that negative connotation has really stuck with ketones. And there are many other reasons why we still today teach that ketones are toxic byproducts of fat metabolism. And so much of what we teach and what we learn about ketones is really flawed or outright wrong. And we don't teach physicians or really any healthcare professionals about the cutting-edge science around ketogenic diets. Now that is certainly changing. especially in the last decade, and even more so in the last few years. There's a lot of emerging research on ketones. In fact, they're now being described as superfuel or longevity metabolites. And the purpose of my presentation, or the objective rather, is really to provide an overview of some of this really quite exciting research. So just as a very brief background, I've been interested in ketogenics most of my adult life. I've been studying them for over 2 decades. Currently in my role as a professor at Ohio State University, I run a research lab. I have an outstanding group that really is focused on ketogenic diets exclusively and other methods of inducing ketosis. Primarily what we do are prospective intervention studies, mostly controlled feeding studies. So we have the infrastructure for preparing ketogenic meals, and we feed those to different groups and clinical populations and even athletes and military personnel. And we take a very broad approach in studying a variety of physiologic and metabolic processes, but our focus over the years and currently has primarily been in the areas of obesity and diabetes, and more recently in cancer and sport performance, and that has really taken us into military applications. And I'll be sharing some preliminary data in some of those newer areas as we go forward. I have to say, professionally, 2 of the perhaps most exciting days of my life occurred last August here at The Ohio State University, where I was honored to be part of the organizing committee for a conference that was specifically focused on the emerging science of carbohydrate restriction and nutritional ketosis. And so you can see on this slide we had over 20 really world-class speakers and researchers, all investigating various areas of ketogenic diets, all the way from basic mechanisms to neurological outcomes, cancer applications, diabetes, both type 1, type 2, obesity, and even sport performance. And I would just like to highlight the URL link on the slide there. We do have quality video recordings of all these presentations that are freely accessible, so anyone interested in additional information on any of these areas, those are about 30-minute lectures that are really quite extraordinary talks. So today I want to cover these various applications of well-formulated ketogenic diets, including metabolic syndrome, type 2 diabetes, cancer, Alzheimer's, and sport performance. But before I do that, I want to provide just a basic overview of what happens when a person eats a ketogenic diet. So when you restrict carbohydrates, eat protein in moderation, there's a reduction in insulin, and this reduced availability of glucose and low insulin environment creates a situation where there's accelerated breakdown of fat in adipose tissue. So the increased mobilization of triglyceride to fatty acid results in an enhanced delivery of fatty acids to the liver, and it's at such a high rate that some of that fat is converted to ketones. So the conversion of fat to ketones in the liver is the process of ketogenesis. Those ketones, specifically beta-hydroxybutyrate and acetoacetate, are then released into the circulation and primarily go to the brain. And from an evolutionary perspective, this was incredibly important. It allowed humans to develop large brains because it was a fuel that could be used and accessed during periods of starvation or any long period of time where there was inadequate food supply. So really what ketones are, they're breakdown products of fat that can be used by the brain for fuel. Fatty acids, long-chain fatty acids, are not able to cross the blood-brain barrier, so this is a way to fuel the brain. And we're now learning that those ketone bodies are having a lot of positive effects, not just in the brain, but the tissue level as well across the body. So promoting brain health, heart health, muscle health, and really overall well-being. So it's really important to understand the concentration of ketones in various states. So in someone who's eating a typical American diet with an abundance of carbohydrate, ketone bodies are very low. Ketones are always being produced, even in that state, but at very low levels. So typically below 0.1 or 0.2 millimolar in the circulation. When you restrict carbohydrates over a period of days, levels are increased tenfold into a range we call nutritional ketosis. And this range is approximately between about 0.5 and all the way up to 3 or 4 millimolar on a well-formulated ketogenic diet. And I want to highlight the fact that even though that's tenfold higher than the carb-fed state, it's an entire order of magnitude lower than the concentration of ketones that is experienced in ketoacidosis. So that's a whole nother level of ketones that only occurs in individuals who are insulin insufficient. So type 1 diabetics or any condition where there's inadequate insulin. And in a person who doesn't have that situation, there's normal negative feedback inhibition that prevents a person from developing those levels, high levels of ketones. So we're learning nutritional ketosis is perhaps the optimal state to be in from an enhanced fuel flow perspective. And when you're in that state over a period of several weeks, the body changes in very profound ways, all the way down to increasing gene expression and changing the way mitochondrial function and the way almost every cell in the body uses fuel. And that the catch-all term to describe all of those changes in their temporal responses is ketoadaptation. Fundamentally, what happens on a ketogenic diet metabolically is that you become very efficient at oxidizing fat. In fact, the rates of fat oxidation double. And that is true whether you're an elite athlete or whether you're an obese type 2 diabetic. Now, the absolute rates will differ, but relatively speaking, the body becomes reliant almost exclusively on using fat and ketones for fuel, and therefore dramatically upregulates its ability to oxidize fat. Now, what we've learned over the last around 5 or 6 years is that ketones are more than alternative fuel for the brain, that the primary circulating ketone, beta-hydroxybutyrate, is actually a potent signaling molecule. So it is having epigenetic effects, and this has been written about in several recent papers, including a science paper that was published in 2012 that really laid out one of the primary mechanisms by which beta-hydroxybutyrate enhances gene expression, and that is through inhibition, HDAC inhibition, histone deacetylase inhibitors. And this is now linked to many other disease processes and even other signaling properties. So in other words, ketones are both fuel as well as signaling metabolites, that they're actually acting more like hormones in many ways. One of the ways they act as a signaling protein is to inhibit inflammation. So we actually have mechanisms now identified how beta-hydroxybutyrate promotes an anti-inflammatory environment. And this explains a lot of the clinical observations that my group has reported, as well as other investigators, that ketones typically reduce inflammatory markers. And there's a growing body of work showing that ketones promote longevity. 2 very high-profile papers were published in Cell Metabolism a few months ago, and both of these studies reported similar findings, basically that mice who were fed ketogenic diets lived longer, but not only did they live longer, they lived healthier. So there was expanded health span. So these mice functioned better both physically as well as cognitively up to the point they passed away. And a lot of the basic mechanisms were worked out in these papers as well. So this is very exciting. It's actually opened the eyes of many basic scientists interested in studying ketogenic diets and longevity researchers. So it seems that all the work on caloric restriction, for example, may be working through ketones as one of the primary mechanisms that explains their anti-aging effects. So what does the evidence look like in terms of metabolic syndrome, which is really a pre-diabetic condition that's driven by, in many ways, overconsumption of carbohydrate relative to a person's tolerance? And on this slide, it shows a number of studies here that have all looked at weight loss as a function of low carbohydrate versus low-fat diets. And there's actually quite significant effects here, and many other systematic reviews and meta-analyses published on this topic, giving the nod to low-carb diets as being more effective at promoting weight loss. And this is one of the more recent meta-analysis that provides evidence for that. And this is a study from my lab group that we published several years ago in patients with metabolic syndrome who were randomized to either a ketogenic diet or a low-fat diet. And one noteworthy part of this study was that we did not specifically prescribe a caloric level. So subjects were asked to eat to satiety. It was an ad libitum approach. And this has been used in many other studies. And when that is done, people who have excess weight regularly reduce their amount of calories they're consuming spontaneously. So there's really no need to count calories on a ketogenic diet, that people are mobilizing their adipose tissue, and so from their cells' perspective, they're well fed even when they're restricting calories. So as you can see here, weight loss was approximately twofold greater on the ketogenic group, and the individual responses on the right indicate that the average weight loss on the ketogenic diet was greater than any individual person on the low-fat diet. And we measured a broad spectrum of biomarkers related to metabolic syndrome or the insulin-resistant phenotype. And across the board, the ketogenic diet is superior at improving those markers. So we see not only does weight loss occur at a greater rate, but there's greater fat loss, especially from the midsection. In terms of cholesterol responses, ketogenic diet is highly effective at lowering triglycerides, increasing HDL cholesterol. And in terms of LDL cholesterol, it decreases the small, more atherogenic particles more so than a low-fat diet. As you'd expect, lowers glucose and insulin, and thereby decreases insulin resistance more. And hormone sensitivity improves. We see decreases in leptin in addition to decreases in insulin, and that is indicative of enhanced leptin sensitivity. And on the far right there, I want to point out that there is a lot of concern around saturated fat intake in general, and certainly on a ketogenic diet, because of its high-fat nature, does contain at least 2 or 3-fold higher levels of saturated fat, which we have been concerned about ourselves, which has prompted us to want to study saturated fat metabolism. And in now, I think, at least half a dozen studies over the years, we've measured saturated fat levels in different circulating lipid fractions as well as tissue membranes. And in all of those studies, we've shown either a reduction or a maintenance of saturated fat levels. Typically, it's a significant decrease. And this is really an important point, because if you accumulate more saturated fat in the body, there is good evidence that you have higher risk for cardiovascular disease as well as diabetes. So despite eating more saturated fat on a ketogenic diet, there's actually lower levels in the body. And what's the explanation for that? Well, it goes back to the metabolic adaptations. You become very efficient at burning fat, including saturated fat. So it's being consumed but promptly oxidized to CO2 and water and not accumulating in cells. This slide shows 7 different inflammatory biomarkers that we measured in that study, and all of these decreased to a greater extent than the low-fat group, again indicative of an anti-inflammatory effect of a ketogenic diet. And in that study, we also performed fat tolerance tests. So we feed people a very high-fat meal, measure triglycerides for several hours after the meal, and quantify that lipemic response. And just like the fasting triglycerides go down, the postprandial lipemic response is reduced by approximately 50%. So people become very efficient at processing fat acutely right after a meal. And that's also linked to improved vascular function. So on the right, we're showing improvements in endothelial function as measured by a test called brachial artery reactivity. Now, we just finished a study, so this is unpublished data, but one of the, I will say, myths or misconceptions around ketogenic diets is that all the effects are due to weight loss. And certainly weight loss is a common manifestation of being on a ketogenic diet and an important one. But in this particular study, we asked the question, could you improve features of metabolic syndrome if people didn't lose weight, so independent of weight loss? So we recruited obese participants with metabolic syndrome and in a crossover fashion had them consume 3 different levels of carbohydrate, ranging from low to moderate to high carbohydrate, and fed them a weight maintenance caloric level, so eucaloric weight level. And you can see on the bottom, weight was maintained across all 3 of these diets, as was body fat. But when we looked at other features of metabolic syndrome, we noted that a majority of participants actually were able to reverse their metabolic syndrome despite the fact that we prevented them from losing weight. So in the low-carb group, 9 out of the 16 participants reversed their metabolic syndrome, and very few did so on a moderate or high carbohydrate diet. And when we looked at cholesterol levels, specifically the particle size of the LDL, which is arguably the most important measure of particles, with the small LDL being the most atherogenic and highest risk for cardiovascular disease. And we see that the low carbohydrate diet was associated with a significant increase in peak LDL particle diameter. And although not shown here, there were fewer small, dense LDL particles on the low carbohydrate diet. And again, coming back to the saturated fat accumulation, when we measured saturated fat in circulating phospholipids, there's a significant reduction in phospholipid saturated fat levels, despite the fact they were eating 2.5 times more saturated fat. So metabolic syndrome is really the precursor to type 2 diabetes. And so what does the evidence show in terms of how ketogenic diets affect type 2 diabetes? Well, this is beginning to now be a very interesting and well-studied area that I've been involved with through a company that, to be fully transparent and provide full disclosure, I'm a co-founder of and have equity in. But the company Virta has taken the knowledge of how to implement a ketogenic diet and coupled that with a virtual care model, sort of telemedicine type technology. And we've studied that in a large clinical trial now, where we're essentially teaching type 2 diabetics how to follow a ketogenic diet, giving them access to a health coach 24 hours a day and a physician that is knowledgeable on how to adjust medications and so forth. And we have published now a couple papers that provide data out to 1 year. We actually have data now out to 2 years that we have in review. And the results are nothing short of extraordinary. So these were patients that were all enrolled in primarily Lafayette, Indiana, central Indiana. It was over a couple hundred participants with type 2 diabetes who were provided this virtual care model to teach them the principles of a ketogenic diet. And one of the big questions now is that people just don't believe that you can stay on a ketogenic diet. I think the evidence is pretty strong that it's effective, but there's certainly concern that the diet's not sustainable. But in our study, we had a high degree of compliance, as evidenced by 83% of the participants who were enrolled were engaged at 1 year. And I can say that it only dropped a very small amount at 2 years as well. So that's really quite remarkable compared to other diet and lifestyle interventions when you look at retention at a year or longer. And those individuals were able to maintain a state of nutritional ketosis. We, as part of our program, measure beta-hydroxybutyrate in a whole capillary blood from a finger stick, and this graph shows that in fact the people on average were able to maintain nutritional ketosis over the year. And unlike the normal progression of diabetes, we are actually able to remove medications. So we're able to get people off insulin and sulfonylureas and other diabetes medications. And not only diabetes medications, but many blood pressure medications as well were reduced or eliminated over the course of the year. And most importantly, we're actually able to reverse the disease in terms of the maintenance of blood sugar. So the hemoglobin A1C is a primary measure of diabetes, with a level of 6.5 being the sort of diagnostic threshold of type 2 diabetes. And at 1 year, almost half of the participants on an intent to treat basis had reversed their diabetes. And 60% of those people who completed the year had an A1C less than 6.5. So we're able to reverse the disease while we're getting people off medication. And as a side benefit, there's significant weight loss. So at 1 year, the average weight loss was over 12% of body weight, so an average of about 35 pounds. And we don't see any indication that weight loss is it's trending back upward. And I can tell you this is maintained at 2 years as well. So this is great news, because we have an obesity as well as a diabetes epidemic in this country. It's really a pandemic. It's a problem all over the world. Every continent is suffering from the diabetes problem, and we have a really remarkable therapeutic treatment option here in terms of nutritional ketosis, and we have a lot of evidence that beta-hydroxybutyrate is sort of fundamentally key to that therapeutic benefit. The challenge, however, is that it does require an intensive and ongoing support, and that is where Virta really comes in and has developed that infrastructure. But with that support and education, it is possible to reverse the normal course of that disease. It's not a progressive, irreversible condition as commonly described by endocrinologists and physicians. So this is really, I think, the most striking and in many ways spectacular example of the therapeutic use of a ketogenic diet is in the area of type 2 diabetes. So some of the newer applications of a ketogenic diet are cancer and neurological conditions. And both of these areas are not as fully developed in terms of a scientific base as obesity and diabetes. But I will say that the preclinical evidence and the rationale for using ketogenic diets is quite strong and encouraging. And it's not a simple sort of reductionist mechanism by which ketogenic diets might improve cancer. It could be through just starving tumors metabolically and switching over to a fat and ketone-based metabolism, but it's also likely related to the anti-inflammatory mechanisms, decreased insulin signaling through PI3 kinase and mTOR, and perhaps even some of the epigenetic signaling mechanisms that we know are attributed to beta-hydroxybutyrate. So I just wanted to briefly mention we have an ongoing clinical trial here at Ohio State. It's called the Keto Care Study, and it's really a feasibility trial, but we're also measuring some pretty advanced biomarkers and actually tumor metabolism in this study as well. It's in advanced metastatic breast cancer, and our enrollment targets are to recruit 20 patients into a ketogenic group and 20 patients into a standard of care low-fat group, and we're implementing a ketogenic diet over 6 months. And I can't share any formal results with you now, but I can say we're very encouraged by the preliminary evidence we have. I can say that certainly the ketogenic diet is accepted by these women across the board, if not embraced by these women. They really have no issues in getting into ketosis and find the diet highly palatable. And we're able to, as I mentioned, quantify tumor metabolism using fluorodeoxyglucose method, which really is looking at glucose uptake into cells. So in these images here, the darker areas are cells and tissues that are taking up glucose at a higher rate. And in this particular woman, she has metastases in the liver. So at baseline, you see quite a few dark spots in the area of the liver. After 3 months of a ketogenic diet, we see there is still metastases there, but it is dramatically reduced, as indicated by the SUV readings on the right. And this has been the case in several of our patients after 3 months of a ketogenic diet. So we're very encouraged by these early results, and as I say, the study's ongoing and hope to have that enrolled over the next year or so. Just as there's a lot of excitement in the world of cancer, and it's not just our group studying ketogenic diets. There are many other trials ongoing with ketogenic diets in cancer. I would say there's equal excitement in various areas of neurology, and perhaps most so in Alzheimer's disease. So metabolically, the brain prefers ketones as a fuel. Another way to say that is the brain will take up ketones in direct proportion to the plasma level of ketones. As you can see on this graph, there's a very nice linear relationship. So the more you're able to elevate your circulating ketones, the greater the uptake of ketones. And we also know that when the brain is fueled on ketones, there's neuroprotective effects. We know, for example, in the area of epilepsy, that a ketogenic diet has significant protection from seizures. We also know there's significant protection from hypoglycemia and all the symptoms of low blood sugar. There's decreased inflammation, oxidative stress, and even some evidence, preclinical evidence, that it's protective against head trauma and concussions. So there's a lot of interest in how ketones affect a variety of different functions in the brain, including just basic neurocognitive types of functioning. And we do have a growing number of studies that have showed better neurocognitive functioning on a ketogenic diet, or in other studies where they provided an exogenous ketone and measured some type of cognitive function. So this is all kind of leading to the hypothesis that a ketogenic diet might be either preventative or even therapeutic for Alzheimer's disease. And Stephen Cunnane has really been a thought leader in this area and has shown that in Alzheimer's, and this is actually true for almost any neurological disorder, that there is impaired glucose uptake into the brain. So there is a metabolic basis to neurological diseases. It's almost like insulin resistance or diabetes in the head. And he has shown that despite the fact there's impaired glucose uptake, there's normal ketone uptake. So interventions that elevate ketones essentially make up for that energy gap and may in that way attenuate the normal progression of the disease. That's the idea anyway. Again, we don't have the randomized clinical trial data yet, so it is still in the early phases of investigation, but again, a lot of interest in and some preliminary evidence to support the use of a ketogenic diet in different neurological disorders. So kind of at the other end of the spectrum, there's another paradigm shift happening in the world of sport, nutrition, and athletes. So, we've been promoting high carbohydrate diets and carbohydrate loading for almost 4 or 5 decades now, going back to the 1960s when carbohydrate loading was really discovered. And we really are witnessing now a lot of momentum and a bit of pendulum swinging in the other direction, where athletes are abandoning their carb loading and instead restricting carbohydrates, and in some cases following a ketogenic diet. And they're doing so with a lot of success. And this is probably taking on more in the endurance world, especially the ultra-endurance athletes. And we've had a chance to study some of these athletes just to try to better understand what metabolic adaptations are happening and how it's contributing to their ability to perform and recover better. So one of those studies was called the FASTER study, and that has been published. We've published a couple papers out of this work and have some data that we're working on that are in review as well. But I'll just share some of the highlights. First of all, we were quite taken back by what extraordinary fat burners these low-carb athletes were. So we basically were able to recruit 10 very elite athletes that were essentially that had been using a ketogenic diet for almost 2 years on average. So they were chronically keto adapted versus a matched elite group of athletes that follow the more traditional high-carb diet. And despite being matched on training status and success in running, you see a doubling of the rate of fat oxidation. These are extraordinary rates of fat oxidation, 50% higher than the highest rates ever reported in the literature. So despite all the training and having good genetics and all these things, simply changing diet to a low-carb diet is able to have a profound impact on your ability to burn fat. And it's not just peak fat burning. These athletes burn almost exclusively fat when they're exercising at race pace. So this is the percent of fat and carbohydrate used during sustained, this is 3 hours of sustained exercise. And it's about 90% of their energy is derived from fat. And that's a huge advantage to these athletes if they're out on the trail running, for sometimes up to 20 hours or longer when they run 100 miles. They don't have to fuel as much during exercise. It's much easier on their stomach, and that's just one of the many potential benefits of being able to burn fat at a higher rate. What was really striking to us, perhaps one of the more surprising results I've ever encountered, was that their muscle glycogen levels at rest and even post-exercise and during recovery were almost exactly the same. No significant difference between the two groups. And I won't go into great detail here, but this has been really fascinating to dig into because there are some credible mechanisms to explain how you can maintain normal glycogen even when you're not consuming a lot of glycogen and exercising and expending a lot of energy. And there are other animal species that do this quite efficiently as well. But the bottom line is humans have a remarkable capacity to recycle carbons in the body to maintain normal glycogen levels, even in the face of very low carbohydrate intake. And we've been interested in military applications and how we can enhance soldier health. And soldiers have a similar problem with obesity and diabetes as the general population. 2/3 of soldiers are either overweight or obese, so it's a real concern. So we just completed and actually published just a few days ago this work in military medicine, where we had a group of Army ROTC cadets on campus who selected into an either ketogenic diet or a control group. And just quickly, you see the consistent weight loss on the ketogenic diet. And this was similar to the previous experiment I described, where we did not prescribe a low-calorie diet here. We asked them to eat to satiety, and you see a spontaneous reduction in energy intake and therefore weight loss across the entire group. And it's not just weight loss, again, it's fat loss. And we actually measured visceral fat in this study using advanced imaging, MRI. And I believe, to the best of my knowledge, this is the first ketogenic diet intervention to show a decrease in visceral fat using MRI. And it was also a training intervention, so we were supervising their training as well. And one of the concerns is, you lose your ability to perform and adapt to training, and that certainly wasn't the case here. There was normal adaptations to the training in terms of a variety of different physical performances, from endurance to strength and even explosive power. So in summary, we are now witnessing the ascension of nutritional ketosis as a powerful therapeutic modulator of disease. And that's especially true for diseases associated with insulin resistance, with type 2 diabetes being the best example, but metabolic syndrome and prediabetes as well. And those are really conditions that manifest themselves as a form of carbohydrate intolerance. If you are insulin resistant, you're not metabolizing glucose in an efficient way. So it makes a lot of sense, just from a rational sort of common sense perspective, that you would limit carbohydrate to a point that you could tolerate. Metabolically, keto adaptation decreases your dependence on glucose as a fuel and dramatically enhances your ability to mobilize and oxidize fat for fuel. And keto adaptation is sustainable with the appropriate amount of education and ongoing support, and can actually reverse many diseases. And we're actively pursuing other applications beyond obesity and type 2 diabetes, and I would say stay tuned. There's a lot of ongoing work in that area that I predict will be published over the next several years, and I believe much of it will likely be positive. So with that, I thank everyone for your attention. I guess I do have one last slide here, which is probably for some in the audience the most important slide, that really deals with the practical aspect of implementing a ketogenic diet. And this could be a topic we spend hours on, but I want to just point out a ketogenic diet is more than just restricting carbohydrate. That's obviously a key component to inducing ketosis, but the way you restrict carbohydrates, it needs to vary from person to person. We find it's best to actually measure ketones in a person because everyone's a little different. So having a objective biomarker to personalize the diet is very effective. On average, people need to get carbs below 50 grams, but some people need to go lower. Some people can tolerate much higher levels of carbs if you're insulin sensitive, and an elite athlete, we see sometimes 80, 90 grams of carbs can be consumed. So actually having a measure of ketones is very important. It's not a high protein diet. That's a common misconception. But it's not a low protein diet either. I would call it an adequate or moderate amount of protein, but getting that in the right range is another critical feature. There's fundamental changes in the way the body handles minerals when you're in ketosis. Notably, there's a natriuresis. There's a loss of sodium. And if you don't understand that aspect of the diet, you're likely to have common symptoms that some people call the keto flu, and they blame it on the lack of carbs, but it's really likely due to hypovolemia or loss of circulating volume that is a manifestation of the natriuresis that occurs. So consuming adequate sodium is really important, and for a lot of people, we're told to minimize sodium. That's really a recipe for failure in the context of a ketogenic diet. And so there's other aspects here to the ketogenic diet that perhaps we can address in the Q&A, but I want to stop there to allow enough time for questions. So thank you again for your attention, and I'll turn it over to you, Dr. Rigby.
Okay. Thank you, Dr. Bullock. Outstanding webinar. We have many more questions that have come in than we'll be able to answer in the time allotted, but we'll just kind of work our way through them. And we're going to take them pretty much in the order they came in. So the first one is not counting calories, but are they still counting macronutrients? If they consume excess protein, won't they go into gluconeogenesis, creating more glucose, thus taking them out of ketosis?
In short, yes. That's why you have to limit protein to some extent. So protein is anti-ketogenic at higher levels. So you do have to monitor the protein intake, and for most people, it's not a low amount of protein either. It actually ends up being around the similar protein intake as people are consuming on a typical American diet, and it's above the RDA. But if you restrict carbs and you try to restrict fat, you end up overeating protein, and that's a big mistake people make, and it prevents them from being in ketosis and ultimately not experiencing the benefits associated with elevated ketones.
Thanks. Next question. This is all great evidence, but would someone have to stay in nutritional ketosis for the rest of their life to continue seeing the positive health outcomes and avoiding the negative ones? Many people I've worked with can't sustain the ketogenic diet for any long period of time. In real life practice, how do you suggest overcoming this? And does it do more harm than good to cycle between the ketogenic diet and the typical American diet? If someone can't sustain it, should they avoid it altogether?
Well, that's a great question, and I wish I had an equally great answer, but it's really highly individualized, and this is where the art of of working with people and trying to find what approach works best with them. But I will say, if you're working with a type 2 diabetic who is, by just nature of the disease, are on the higher end of insulin resistance, we're finding that they more or less do need to stay around, at least the lower threshold of nutritional ketosis in order to maintain optimal benefit. Having said that, there are people. Not everyone needs to be on a ketogenic diet to maintain good health, and there are people who initially go on a ketogenic diet and experience a lot of weight loss and improvements in their metabolic health, who can then incorporate some carbohydrate back in their diet, such that it's low carb but not ketogenic, and they're able to maintain those benefits. Now, maintaining anything is not easy, and so I certainly understand and sympathize with the comment about challenges in maintaining this, and that's where the ongoing support comes in. I mean, we can't underestimate the massive forces out there that really want you to eat a lot of carbohydrate, and so helping people manage that sort of toxic environment we live in requires a lot of effort and support to do that. So there's no cookie cutter, one size fits all, simple answers here. But at least we have the data now that ketosis is safe. It's not only safe, I would argue it may be an optimal metabolic state to be in. So the challenges are more, how do we help people maintain this diet? And I do believe it's getting easier all the time, in part because there are companies now that are developing appropriate ketogenic products that make it more accessible, for people to do this, and easier for people to manage, traveling and going out to restaurants and so forth, which is all positive. But at the same time, it still is challenging. I don't want people to think that you can give people a book or a few pamphlets and send them off. There's very low chance they'll be successful. This is something that people really need a lot of help and support with.
Thank you. Next question. Do you believe that a lower carb, high fat diet, i.e. 60% fat, 25% protein, 15% carbs, would have some of the effects of the ketogenic diet despite not going into nutritional ketosis?
Yes, again, that's a great question and very relevant question too. Again, no simple answers here. I think for a lot of people there could be benefit. If you're getting rid of sugar in your diet and improving the quality of the carbs you're eating as you're cutting back a little bit on carbs, certainly there's some health benefit that would likely be gained from that sort of dietary manipulation. But you would not be experiencing any direct benefit attributed to ketones and beta-hydroxybutyrate. So, for example, with type 2 diabetics, I think there's good evidence now that for optimal benefit, you need the ketone elevation. But that's not to say there wouldn't be some benefit from just displacing some of those more toxic carbs like fructose with higher quality carbs. So I don't know if it's a linear benefit, but I view ketogenic diets as sort of the island of safety. If you want to ensure that you're going to get the most optimal benefit, aim for the ketogenic diet, but if you fall short, there's a good chance you'd still get some benefit. Where I do worry a bit, if you're restricting carbs but not enough to induce ketosis, you may be in a kind of gray area where you don't have optimal supply of glucose to the brain because you're limiting carbs, but you don't have ketones available at high enough level to fuel the brain either. So the brain is kind of in the middle, not getting adequate ketones or glucose. So there could be some issues with that, especially on a low-calorie diet.
Thank you. Next question. Is there any research regarding the ketogenic diet and the gut microbiome? Are there any common side effects, such as constipation, given a very low carbohydrate diet will likely lead to a decreased fiber intake?
So the area of ketogenic diets and gut health has not received a lot of direct investigation. But I will say anecdotally, from a testimonial perspective, we see a lot of people with gut problems. We see their symptoms improve on a ketogenic diet. And we think one of the reasons is the gut, loves butyrate. And that's one of the reasons we promote high fiber, because bacteria convert the undigestible carbs or fiber into butyrate, and the colonocytes function very well on butyrate, and there may be anti-inflammatory effects of butyrate. But on a ketogenic diet, you're producing a form of butyrate because the principal ketone body is beta-hydroxybutyrate, and your liver is producing about somewhere between 50 and 100 grams of beta-hydroxybutyrate per day, and a lot of that, or at least some of that, could be going to the gut to promote health. So in other words, if you're suppressing ketones, fiber is probably requisite in your diet in order to provide a source of butyrate. But if you're restricting carbs and your liver's producing a form of butyrate, there's not as great a requirement for fiber in the diet. Now, that's not to say you don't get fiber, because you eat non-starchy vegetables and nuts and seeds. You can get decent fiber, but it's just not as important because you have another source of butyrate. In terms of side effects, was that part of the question too? Constipation. Yeah. I think. Yeah. Some people do experience it, but we find it's not because of lack of fiber, it's often a sodium issue. That if people drink broth, that especially homemade broth is preferred. That often alleviates the constipation. It's just more of a fluid issue, more so than a fiber issue. So that's not a big concern.
Thank you. Next question. Based on your information on the unpublished data that maintaining weight improved health parameters on the ketogenic diet, do you think this data would support the health at every size movement?
I guess I'm not familiar with that specific movement. And what we did in that study was, it was experimentally. We were trying to address one of the concerns or, sort of paradigms around whether or not obesity is a stimulus or a response. And I always view it as a response. So in the real world, people do lose weight on a ketogenic diet that have weight to lose anyway. And so we almost, in some ways, handicapped the low-carb diet by preventing weight loss, and yet we still saw a lot of metabolic benefit, which confirms sort of our idea that a lot of the benefit of the ketogenic diet is driven by the carb restriction, not the weight loss per se.
Thank you. Next question. In the study with 83% compliance at 1 year, what was the breakdown of carbohydrate, fat, and protein in the diets? Or did you use a certain number of grams of carbohydrate instead of percentages?
So in that study, we did not quantify food intake. We were really focused on teaching them how to get into nutritional ketosis, and in terms of what foods they could eat to induce that metabolic state. So the fact that they were able to get into nutritional ketosis tells us better than any dietary assessment method that they were in fact restricting carbohydrate and consuming protein in moderation, because those are the two dietary factors that determine ketosis. So we don't have that, the diet assessment information, but those metabolic biomarkers tell us that they were restricting carbs effectively. And as a dietitian and having done a lot of dietary assessments, I mean there is value to doing them, but we also know that everyone lies, so you have to question the validity of a lot of those methods, even if you were using them in studies.
Okay, next question. How does KD compare to intermittent fasting metabolically and in ease of use?
Well, there's been a lot more research on ketogenic diets than intermittent fasting. And there's many different types of intermittent fasting. And so it's not really possible to do a direct comparison right now between the two. One of the benefits of a ketogenic diet is that you have much more stable fuel flow, so that you don't run over an energy cliff if you miss a meal. And that is very empowering. One of the most common perceived benefits that people talk about is that they're not as hungry, there's greater satiety, they can go longer periods of time without ingesting food. So the concept of eating 3 meals a day plus 2 snacks, it goes kind of out the door on a ketogenic diet, because most people are fine if they eat a couple meals a day, sometimes even 1 meal a day. So I guess in practice a lot of people end up practicing a form of intermittent fasting on a ketogenic diet.
Okay, thank you. I'm afraid that's all the time we have for questions. We have many more, but we just simply have run out of time. I'd like to now repeat the objectives for this webinar, and that is that following this webinar, participants should be able to, number one, overview the process of switching from a carbohydrate to a fat-based metabolism through dietary carbohydrate restriction. Number two, discuss ketone metabolism and define nutritional ketosis and keto adaptation. Number three, discuss how a well-formulated ketogenic diet affects the constellation of markers associated with insulin-resistant conditions, including the reversal of type 2 diabetes. Number four, review other clinical and performance applications of ketogenic diet. I would now like to turn the webinar over to my colleague, Amy Continelli.
Thank you, Dr. B. A link to obtain your continuing education credit certificate will be available on the website and emailed within 2 days. Today's webinar will be available to download within 2 days at ConAgraNutrition.com. And for any questions regarding your continuing education credit, you can email nutrition@conagra.com. Thank you for supporting NutriBytes webinars for the past 10 years. Regrettably, today's webinar by Dr. Volek marks the last webinar in the NutriBytes series. CEU certificates will be awarded for attending today's live webinar. However, this webinar will not offer the option of taking the online quiz after the live webinar. Completing quizzes after viewing past webinars online to obtain CEU certificates will no longer be available after March 25th, 2019. The entire series of NutriBytes webinars will remain on the ConAgraNutrition.com website for the long term, with an option to view the presentations and download slides. If you have questions about any past CEUs or other questions about NutriBytes webinars, please again contact ConAgra at nutrition@conagra.com. Thank you, Dr. Rippey.
Thank you, Amy. This is Dr. Rippey again. I want to thank all of our webinar participants over many years. It's been a long run. We have had over 25,000 people participate in these webinars, and I know it's your valuable time, and so we very much appreciate that. My organization, Rippey Lifestyle Institute, has had the pleasure of coordinating these webinars for a decade, and so we're very, very proud of that. And finally, I'd like to thank ConAgra Nutrition, ConAgra Brands, for having the staying power to stick with this, what I think is a very valuable nutrition education for a decade. So it gives us all great sadness that this is coming to an end, but we've had a good run, and there are many people to thank. And then finally, for just the moment, I'd like to thank Dr. Volek, who just gave an outstanding webinar. I challenged him to bring it home for us after this decade in a high-level fashion, and he certainly did. So thank you all for your participation. Thank you, Dr. Volek, for an outstanding webinar, and let's hope we can resuscitate this kind of effort sometime in the future.